Hello differential equation students. In this video we'll learn about exact differential equations. We'll figure out what they are and how to solve them. An exact differential equation has the form m of xy dx plus n of xy dy equals 0, where partial derivative relationships of m and n are given as follows, where partial n partial x is partial m partial y. This condition should be familiar to you from multivariable calculus. So if we recall Calc 3, this condition seems natural. To solve exact differential equations, we use the following fact. There is a function phi of x and y such that two things are true. Such that 1, partial phi partial x is m, and partial phi partial y equals n. And 2, the solution to the exact equation is phi of xy equals c, our constant. Let's take a look at an example and see how we can apply this method. Let's consider the following differential equation. 2xy plus 1 dx plus x squared minus 1 dy equals 0. To check to see if this is an exact equation, we need to verify that this boxed condition is true. So let's check that. This function over here is our m. This function over here is our n. So partial m partial y. We hold x constant. The derivative of 2xy with respect to y is 2x. The derivative of 1, which is a constant, is 0. So partial m partial y is 2x. Partial n partial x. We look at n and we hold y constant. Well, there's no y's here, so I do the derivative as ordinary. The derivative of x squared minus 1 with respect to x is 2x. So both dm dy and dn dx are 2x. So my exact condition is satisfied. I can now proceed to find the function phi, which gives me my solution. We know from the theory that partial phi partial x is equal to m, and m is 2xy plus 1. I can undo this partial derivative by doing a partial integral. I will hold y as constant and integrate with respect to x. So if I integrate with respect to x, I see that phi of xy, the integral of 2xy, treating y as a constant, I only look at the integral of 2x. The integral of 2x is x squared, so I will have x squared y. And the integral of 1 with respect to x is just x. And whenever I integrate, I have a constant, so I put a plus c over here. Now we should pause and realize that I did a partial integral, so this constant is not an actual constant. This constant must depend on the other variable y. We now use the second condition, partial phi partial y equals n, to determine what this function c of y is. So I can compute the y derivative of this, partial phi partial y. The derivative of x squared y with respect to y is x squared. The derivative of x with respect to y is 0, since we treat x as a constant when we do partial derivatives with respect to y. And the derivative of c of y will be c prime of y. But condition 2 tells us that partial phi partial y is n, which is x squared minus 1. Relating these two equations, I see now that x squared minus 1 must be equal to x squared minus c prime, which tells me that c prime of y has to be negative 1. If c prime of y is negative 1, that tells me that c of y is negative y. And now I look back at my representation for phi, and I can substitute in c of y. So our solution will be x squared y plus x minus y equals our constant c. Since the solution to the equation is of the form phi of xy, this function equals a constant c. Thank you.